start from the next. Welcome, we're Team 21023. Our task is to build a kitchen standard that can help cerebral palsy patients sit and stand at the kitchen counter so that they can perform their regular tasks at the kitchen counter. Our main requirements were that the user should be able to sit and stand while being fully supported at all times. Safety was our primary concern. The standard shelves should be easy to transport and cost effective, and should also be adjustable so it can accommodate the dimensions for the growing child. We aim to procure the materials that are commonly available and devise a procedure that anyone can follow if they want to build their own kitchen standard. We want to introduce ourselves. I'm Neil. I'm a fifth year mechanical engineering student.
I'm Jacob. I'm a fifth year biomedical engineering student.
I'm Alex.
I'm Connor, and I'm a fifth year mechanical engineering student.
And I'm Alex, and I'm a fifth year mechanical engineering student as well.
So our first design in creating this device, we made an entirely wood frame and wood seat. We also wanted to create a mechanism that would secure the stander to the kitchen countertop. This turned out to be extremely heavy. It was a lot of wood. And we also decided the method of attaching the stander to a kitchen countertop was not entirely effective. Also, the wood assembly would not be adjustable for as the child grows. Next slide. So in order to solve this, we decided to go with an aluminum frame. This greatly reduced the weight of the device, and it also allowed us to use a telescoping feature to make the size of the device adjustable. Also, by using an aluminum frame, we can remove the seat portion and allow it to be more portable in smaller pieces. We also decided to use a system that allows for stability on the sides instead of locking to the counter.
So as Jacob said, one of the main goals for this project was adjustability. We wanted the standard to be able to use for a child at a young age and to be able to adjust it without having to buy new parts as the child grows and still be able to accomplish the same tasks that we said at the beginning. So as you can see in the middle there, we added a telescoping feature with the aluminum tubing, which will allow the base to grow. And then we added extra stock to the middle portion and to the back seat. That way new holes can be drilled and different portions of the seat can be adjusted to adjust with the size of the patient that we're taking care of. As seen in this video on the left here, instead of the counterlock mechanism that was going to really get in the way and prevent some of the tasks that we really wanted the patients to be able to do at the counter, we went with a adjustable front piece that would rest up against the front of the counter and prevent a forward tipping motion. And on the sides will be foldable bars that will fold down and will prevent side-to-side motion, which will increase the safety of the stander and keep our patients safe at all times.
We faced some challenges along the way. The first one being the pump that we bought would actually take a lot more pumps to get to the fully extended height. So we have to devise a new mechanism that would be faster and much more accessible for the user to go from a fully distended state to a fully extended state. Also, the lead times we need for aluminum have been taking longer than anticipated, which is making us wait longer for actually building out the standard. And we're strictly following the COVID-19 guidelines that RIT has proposed, but we're still not sure how or when the future of our build would go.
So in this slide here, we will show images throughout the assembly process of the aluminum seat, the pump being attached, and other components being assembled. This will be more formulated in the next upcoming weeks and will be incorporated into the next version of our slideshow. Same thing with this slide as well. This will be a video once the final assembly is complete, either showing weighted portions in there or an actual patient going through the process of the sit to stand motion and showing the different mechanisms that we have on our device. And again, this will be incorporated in the next version of this presentation.
As we built each part of the standard, we had to make sure that the goals that we set at the beginning were met, and in order to figure out if those standards were met, we had to test. So here is the outcome of those tests. We can, using these test results, we can see that the requirements that we set at the beginning were met. Currently, we have the base built and are testing its weight capacity. We're working on solutions to more efficiently activate the pump, and we're waiting on our aluminum to arrive. We want to thank RIT for all of their support, including the funding and the space that they provided. We want to thank Harold for his help and his guidance throughout the whole each semester. We also want to thank Trevor and Grace's families for their support and their guidance in this project as well.